Okay, so we're going to start the first part of your air pollution notes today. I've divided these notes up into two different sections. We're going to do the outdoor air pollutions notes first, and then another day you will do the second part, the indoor air pollutants. So let's begin. And I apologize if some of the formatting is off. When I use the software, it messes with the format a little bit. So first we'll start with the different types of air pollutants. And originally, it also defines what air pollution is. It says it's just the presence of one or more chemicals in the atmosphere. It can cause harm to humans, other life forms, and materials as well. We'll learn that some things can oxidize materials and harm plants. So it's not just humans. It could be man-made materials and even other life forms. So anyways, we have two different types of pollutants that we can categorize. Your primary pollutants are just those raw pollutants that come directly from the source, whether it be maybe a smokestack or an exhaust pipe, but we actually see that primary pollutant come out before it's been changed into anything else. And so we'll learn about some of those primary pollutants in a moment. And then you can also form what's called a secondary pollutant. And so once the primary pollutant has been released, it can react with things such as sunlight, water, any free oxygens roaming around in the atmosphere. Those can all react with the primary pollutants to form these secondary pollutants. These secondary pollutants are usually more toxic, and they can cause some problems. Okay, different sources of pollution. You can have what we consider stationary sources. So those are going to be things that don't move. So a lot of pollution comes from power plants that are used to generate heat and power. Factories and industry, especially in like commercial industries and purposes. Burning of any sort of plant material, and really the burning of anything, incineration of anything, because we'll talk about incineration of trash later. That gives off a lot of pollution as well. Solvents are chemicals that are used to dissolve things. A lot of these can be very toxic, have very strong odors and smells, but those, when they dissolve things, they can give off pollutants as well. And then aerosols, which we'll get to in a moment. We're going to learn that most of the air pollution comes from mobile sources, especially these guys, especially highway traffic. But they say they can actually narrow down. They say that these single car riders, and we have a lot of that in this area, people who commute long distances back and forth all by themselves in their cars, they give off a lot of pollution collectively as a group. So again, mobile sources, things that are moving, so cars, trucks, buses, motorcycles out there on the highways, they give off a lot, very high percentage of the air pollution. Aircrafts, boats, trains, farm equipment, RVs, construction machinery, even your lawnmowers, even little tiny things that you don't think about. Anything that uses that fuel is going to give off some sort of air pollution. You can use the push lawn mowers that are just operated with blades that don't use any sort of fuel, if you want to do that. And we'll talk about that later when we get to different energy resource use strategies. But anyways, so even these little kind of trivial things can give off air pollution. And then you have some natural sources of air pollution. Volcanoes give off particulate, sulfur dioxide, and then you also have sea spray from the ocean, dust, erosion, decomposition. Those all give off different types of air pollutants. Okay, this is an important diagram because it shows us, what's happening between primary and secondary pollutants. And again, we just talked about some stationary sources like factories and power plants, mobile sources like vehicles, natural sources like volcanoes. Those all first emit these primary pollutants. So we're going to be talking about a lot of these different compounds and molecules today, so I'll kind of introduce you to some of them. CO is a primary pollutant, that's carbon monoxide. CO2, carbon dioxide. SO2 is sulfur dioxide. NO is what we call nitric oxide. NO2 is nitrogen dioxide. Hydrocarbons are going to be molecules that are made out of carbons and hydrogens, so it's going to be a lot of fuel type things like methane, benzene, propane, those sorts of things. Suspended particles, again, particulates are given off by all three of these different sources. And then these, we said that they can react with sunlight, they can react with the water molecules that are up here, they can react with any free oxygens that are up here, and we'll talk about how oxygens get loose a little while later. They can react with those, and we can form these types of things, your secondary pollutants. So again, just to kind of introduce you to some of these. Oop, and this one didn't show up. This is supposed to be SO3, which would be sulfur trioxide, which is like a precursor to, could be a precursor to this guy, which is sulfuric acid. So yeah, H2SO4, that's sulfuric acid. HNO3, that is nitric acid. So these are both compounds that would play an important role in, you guessed it, acid rain. This is peroxide. We're not really going to talk much about that this chapter. O3, ozone. We will be talking a whole lot about that all throughout air pollution stuff. These PANs, we'll come back and get those in a second. And then you have some salts that can form as well. Okay, so just one more time, some different sources of your, here it calls them air toxics, air toxins. Stationary sources like factories, power plants. Accidental releases could be toxic chemicals that are released, solvents, giving off fumes. Mobile sources is the big one, your traffic stuff. And then again, as I said, anytime you're burning something, could be forest fire, could just be leaves or plant residues or whatever, you're going to be giving off particulates and pollutants. Okay, and then this pie chart, one of the big things I wanted you to realize, again, is that mobile sources give off a lot of air pollutants. And then you have a figure over here that's hidden, but it just says that 54 million metric tons of mobile sources in 1990. These were the data back then, but they said that's gone up even more since then. Okay, so this is an important slide. We have in our country, the EPA, Environmental Protection Agency, has established 6 what we call criteria pollutants. And we consider these as indicators of the air quality. And if we come down here before I introduce those to you, it says that they have established for each one of these criteria pollutants certain concentrations above which we could expect to have bad health effects. Okay, so when we talk about the Clean Air Act in your next set of notes, Clean Air Act is really going to focus on these 6 guys and trying to bring the emissions of these 6 criteria pollutants down. Okay, so the first one is NO2, which is nitrogen dioxide. We have ozone. Now, we have 2 different types of ozone. The one that's at ground level where we live is bad. We do not want ozone down where we live. Now, in another couple of units from now, we're going to talk about stratospheric ozone, which makes up the ozone layer. That is good. That's protective to us. We need that. But when you have ozone down around us, that is a pollutant, and it's harmful. Okay, so that's O3. Carbon monoxide is CO. Lead, PB. Particulate matter, we just abbreviate that with PM. Sulfur dioxide, SO2. And then VOCs, we'll come back and talk about these in a moment. Those stand for volatile organic compounds. Okay, so we're just going to run through these one by one. We'll start with sulfur dioxide. Colorless gas, has an irritating odor. What I want you guys to know is that whenever you think of coal or you hear about coal, you should automatically think sulfur. Okay, so burning of coal that has sulfur in it is going to be one of your big things that gives off sulfur dioxide. Okay, and then it also has here burning of any oil that has sulfur in it as well. But your big guy, when you think of sulfur, you think of coal, think of the other one. They go together. Coal gives off a lot of sulfur, and that's going to cause some problems, especially we're going to watch a video that shows what's happening in China. They burn off a lot of coal. It's very cheap, but it's very dirty, causes lots of air pollution. Okay, you can also give off sulfur from the smelting of metals. Smelting is when we extract an ore. We did our mining unit. So you extract your ore. You have to melt off the metallic product that you're trying to get from that ore. Okay, so when you smelt the ore, it's going to release sulfur dioxide as well. And then also making paper gives off sulfur dioxide. We have some natural sources of sulfur dioxide, sea spray, volcanic gas. That's kind of a big one. We talked about that at the beginning of the year. That sulfury stuff, it always smells kind of eggy. It's got that bad smell. You see that a lot with geothermal activity. And then waste from bacterial decomposition. So yeah, even natural processes like decomposition can give off some pollutants. The effects of sulfur dioxide, it says once it hits the atmosphere, it can form sulfur trioxide. That is a precursor to H2SO4, which we said is sulfuric acid, and then that would be involved in acid rain. It can also cause breathing difficulties. Okay, so that's it for sulfur dioxide right now. Now, before I get to the next one, when we go on to these NOs, a lot of times when I'm talking about sulfur dioxide or sulfur trioxide, last year I would call them SOs, but we learned in AP training that a lot of times it's easier to call them SOx. So you'd say SO, and then X down here is your unknown variable. It's our unknown number. That represents, it could be 2, it could be 3. So a lot of times when you're talking about these SOs, we'll just call them SOXes. And then for the next group, your NOs, we call those NOxes. So the SOXes and NOxes, you should just get used to me saying those. Those are going to be your SOs and your NOs. Okay, so for the NOs, or the NOxes, we've got a couple of different types of NO groups. You have NO2, which is nitrogen dioxide. That's released when fossil fuels are burned, especially like in a car. Okay, you get a lot of NOs from vehicle emissions. You can have regular just NO, that is nitric oxide, and that can react with molecules in the atmosphere to form NO2, which can react with water vapor then to form HNO3, which is nitric acid. And I already showed that to you earlier as well. Nitric acid is also another secondary pollutant that is involved in acid precipitation. Okay, so HNO3. Effects of these NOxes, again, they can lead to acid rain, they can cause lung and heart problems, they can cause decreased visibility because NO2 can cause a yellow haze, and then also it can react with other stuff to form photochemical smog, and I'll show you the reactions for that in a little bit. They can also suppress plant growth. So NOs are going to come from fossil fuel combustion, power plants, forest fires, volcanoes, bacteria again. And remember, in our nitrogen cycle, we did talk a lot about the bacteria in the soil, so they can release nitrogens back into the atmosphere. And then one more NOx, one more NOx is N2O, and that is nitrous oxide, which is a greenhouse gas. And we'll come back and talk about that some more in climate change in a couple weeks. And this is mostly going to come from farming, agriculture, and fertilizers. Okay, on to ozone. Ozone is O3. That's very important to know. We'll talk a lot about this guy all throughout this month. So ozone can form when you have an NO2, nitrogen dioxide, loses an oxygen, and that's going to happen. A lot of oxygens break loose from molecules when the sun beams down. So sun is going to shine its little rays down, and let's see if you've got an NO2. So you've got N with an O and another O. So the sun rays can shine down on it, and it can break off these oxygens off of the ends. Okay, so anyways, it says NO2 can lose an oxygen, and then that free oxygen, you get a lonely little oxygen, it can join up with other O2s, which is how oxygen naturally exists in the atmosphere, to form O3. Okay, so whenever you get a little loose O, it can bond up with O2s to form O3. Sources of ozone. So it says it's actually created by sunlight acting on these NOxes and then some other molecules too. It can knock oxygens off of other things like VOCs as well. Photocopiers give off ozone, believe it or not. Cars can help in this problem. Industry, vapors, solvents. Incomplete fuel combustion. Now, incomplete fuel combustion happens all around us. They say pretty much every type of burning of fuel reaction is going to be an incomplete reaction. And all it means to be an incomplete reaction is that when you do this reaction, there's not enough oxygen to complete the reaction fully, and it means whatever chemicals weren't consumed during the process, they're going to be given off as products. So what we see given off in incomplete combustion, a lot of times you see carbon dioxide, water vapor, and then any other products, again, that weren't completely used up during the reaction. So we see that with cars, factories, all that sort of thing. It's called incomplete fuel combustion. Okay, effects from ozone. It says ozone is a large component of photochemical smog. That's going to come up here in another couple slides. It can damage vegetation. It can damage buildings. It can damage the mucous membranes within our bodies, which can cause coughing and lung irritation. And it says thousands of people are hospitalized each year due to ozone-related illnesses. Air pollution's come under a lot of scrutiny with health stuff this year. I just saw something on the news a few weeks ago that said, oh, they finally linked air pollution to thousands of deaths. So we'll look at some articles during this unit, but people do die from air pollution, even in this day and age. Particulate matter. Okay, so it says these aerosols are liquids or solids suspended in gas. So yeah, I guess technically we consider an aerosol is a liquid or solid. And then these are all considered particulates. So some example of any type of particulate would be soot, dust, ash, smoke, etc. So really anything that causes the air to be dusty, smoggy, foggy, those could all be considered particulates. These are frequently caused by fossil fuel combustion or incineration burning of anything. Again, you're going to burn something, it is going to release particulates into the air. It says power plants in the U.S. usually control particulate emissions. So power plants are pretty good at not giving off a whole lot of particulates. So most particulates in this country come from diesel emissions. Who uses up a lot of diesel? Well, that's going to be a lot of your big rigs. Okay, a lot of those larger vehicles out on the highways, those 18-wheelers, they use diesel. And then you can also still buy smaller, like sedan, coupe-sized cars that run off of diesel too. I know I used to have a friend when I was younger who had a Suburban, big old SUV that ran off of diesel. So some cars, that you can own privately still run off of diesel as well. Diesel is good; it gets you good miles to the gallon, but it burns really dirty. So that's the problem with diesel. Small particles. The smaller the particulate, the worse. So the smaller particulates are actually more harmful, as they are more likely to be deeply inhaled. They can affect lung tissue. These are linked to heart attacks, asthma, bronchitis, lung cancer. And the larger particles are not as harmful because they usually get trapped in your hair or your mucus lining. Okay, some of your COs. So we have just regular old CO, that's carbon monoxide. Colorless, odorless gas produced from incomplete combustion of fossil fuels, again, usually from car exhaust. This is scary. This is something that people die from on accident. I don't want to say all the time, but you always see stories in the news about people accidentally getting carbon monoxide poisoning in their own homes. So it's really, really, really important to have a carbon monoxide detector in your house. We have two of them. We have one on our upper level and one on our middle floor. We should have one in our basement too. But if you have a carbon monoxide leak in your house, again, you're not going to smell it, you're not going to see it. It's going to cause all these things. It can make you feel dizzy and nauseous, and you can eventually die from it, especially if you're asleep when this starts to happen. I remember there was a story in the news last year about a woman who lived in a townhouse, and townhouses are all joined together. Her neighbor, to one side of her in her townhouse, left the car running in the garage on the base level, and the carbon monoxide from the car running in the garage seeped up into the nearby townhouses, and one woman almost died. Luckily, they caught it, and she was okay, but she had to be hospitalized. So kind of scary. CO2, carbon dioxide, we'll come back and talk about this much, much more with climate change, but it just says here, a major source is cellular respiration, which is a natural source. natural process, but it is increasing due to lots of deforestation, the burning of forests, combustion of fossil fuels. We know it is a greenhouse gas. It can also react with water to form a type of acid called carbonic acid, which would be a player in the acid rain issue. Okay, on to lead. Lead is a grayish metal. Largest source used to be from leaded gasoline. We used to put lead into gasoline, but that's now been banned in the U.S. We don't do leaded gasoline. They still do leaded gasoline in other countries. So anyways, us banning lead from gas has lowered the levels in human bodies in our country. What's scary about lead is that it bioaccumulates. It says it can bioaccumulate in your bones. And what it does to your body, the main thing it does is it reduces the ability of the red blood cells to carry oxygen. So it says it can lead to developmental issues like retardation, ADD, impaired IQ, especially in children. It can affect pregnant women and their unborn babies. Sources, it can come from particulates, smelters, batteries, paint. So we do still have to worry about lead a little bit in this country. If you live in an older home, they say any homes built before 1978, the paint probably contains lead. So if you have painted over old walls with old paint in an older house, and for some reason some of that older paint kind of cracks through, it can contain lead, and if a kid gets a hold of it and they bite on it or chew it, then they can get lead into their body. And they say that lead paint is actually very sweet because lead has a sweet taste to it. So that's a big danger there. It's also found in old pipes in old homes, so it can contaminate water. So older homes are really the ones that have to deal with lead. If you live in a newer home in this area, then you're probably okay. Okay, VOC stands for volatile organic compounds. These are going to be mostly hydrocarbons, which I've already told you guys that's carbons and hydrogens. So like methane is a good example. Methane is just a carbon with 4 hydrogens all around the edge, and I would draw all 4 of them, but it's going to take me a while. Okay, they usually evaporate easily. They're very strong smelling. Some examples of these, synthetic ones, meaning man-made ones, are formaldehyde, really stinky. If you've dissected animals, you've smelled formaldehyde. Benzene, toluene, vinyl chloride, phenols, chloroform. Again, we've heard about that. That's the pass-out thing that you always see people in movies put the cloth over somebody's mouth and it makes them pass out. So they're really smelly, stinky things. They can be released through the combustion of fossil fuels, especially cars, refineries. We'll talk about those with fossil fuel, refining fossil fuels. Chemical plants, evaporation of solvents or fossil fuels. So, you know that when you're filling up your tank of gas and you're like, it smells kind of weird. That's the smell we're talking about. Aerosols, paint thinners, dry cleaning, and ironically enough, a lot of people actually like the smell of this stuff, but it's bad for you. Even like those dry erase markers, kind of that weird stingy smell. A lot of people like that smell. It's not good for you to breathe in. Natural sources. Gases naturally produced by forests and bacteria. So an example of a natural VOC would be methane gas that's produced in anaerobic respiration. So little bacteria that live in the absence of oxygen, they make methane. Effects of VOCs. They can do they can cause ion respiratory irritation. Some of them are carcinogenic, meaning that they can lead to cancer. Some of them can do liver, central nervous system, and kidney damage. They can damage plants, especially at the ground level. Well, of course at the ground level. Lowered visibility due to brown haze and global warming. And again, some more examples are methane, benzene, and some CFCs. So kind of that stinky stuff. Mercury. Mercury can be released naturally from volcanoes and weathering of rocks and evaporation of seawater. Anthropogenically, meaning man-made reasons, from coal combustion. That's the big one here. And this is another big downside to using coal. Not only does it burn really dirty and give off sulfur, but it also gives off mercury. So bad. Incineration of stuff can give off mercury, and then smelting, which we already talked about before, that's releasing the metal from an ore, that can give off mercury as well. Humans can be exposed to mercury from eating contaminated, especially fish, because fish can contain high levels of mercury when mercury gets into water. Some of the worst fish to eat, some of the fish you would not want to eat if you don't want to have exposure to mercury would be grouper, marlin, swordfish, which I happen to like. I eat a lot of swordfish, but I wasn't allowed to eat that when I was pregnant. Shark, halibut, and tuna. So, if you are a young child or you're pregnant, they say stay away from those types of things. So, unfortunately, you also have to stay away from sushi because they use tuna in a lot of sushi. What mercury can do, it can lead to brain damage. It can cause poisoning to fetuses. So, again, that's another reason why pregnant women have to steer clear of a lot of fish. Not a lot, but those specific groups. Okay, here's a chart that kind of breaks down those 6 criteria pollutants we just talked about, and actually they've added in your VOCs here at the end and ozone. And it shows you some of their major sources, it shows you some of the health effects, it shows you some environmental effects. You guys are actually going to do your own chart in class as well, so I'll include this in your note packet so you have that there for you already. Okay, we need to talk about the different types of smog. You've heard me mention this photochemical smog a couple of times already. When you see photochemical smog, when you see that prefix, you should always think light. Okay, so this one is going to be accelerated and created by sunlight. Okay, we call this the brown air smog. This is the type of smog you see out in LA. It says it's a mixture of primary and secondary pollutants formed under the influence of sunlight. Says it typically occurs in warm, sunny areas with large number of automobiles. So a lot of times it happens in really busy cities on warm afternoons, after you've had plenty of sunlight and after you've had lots of highway traffic out there to get all these precursors to the smog up there in the air to react with each other. Okay, so what we have happening here, it says nitrogen and oxygen in the air, they react at high temperatures found in automobile engines and boilers of industrial plants. They produce the NOs, which can react with oxygen to form NO2. And then the NO2 can start to cause some brownish haze. But NO2 can react with some other stuff as well. Okay, so here's even more of a reaction. Oops, what is that? You can have NO2s, we can form ozones eventually, and then we can have these PANs, which are peroxyacyl nitrates. They are formed from NOxes and VOCs, and they're going to be similar to ozone. Okay, so NO2s, ozones, these PANs, these VOCs, they're all out and being formed in these sunny afternoon, high congested traffic situations, and that's where you get those smoggy cities. Okay, so that's what that's saying here. The effects of these, they can irritate respiratory tracts, they can damage plants, and of course they cause that unsightly haze and smog. Okay, so here I wrote this up right before I started. Here's kind of a breakdown of the different reactions that can happen. So you get these NOs that are released from the combustion of fuels in cars and factories. NOs and then oxygens, and again you're going to get little mini or separated O's, so not O2, but you get little lonely oxygens that can come and react with an oxygen from this, or you can split this apart and get an oxygen that comes and joins up with that. Anyhow, you're going to get NO2s from that reaction, and then you can get either NOs or NO2s that can react with some of those VOCs, those smelly things we talked about, and then you can get some ozones. So there's lots of different possible ways to get O3s, but anytime you're breaking off oxygens and they're separate from each other and then they have other O2s to go and react with, you can get ozones. And then again, that's bad, that's going to lead to that photochemical smog. And this is very reactive with things. Okay, here's another diagram showing you some of the stuff that's happening here. So again, sun plays a big role in this. It's going to hit these NO2s and NOs. We have water vapor. We have atmospheric oxygens. Here's your regular O2 that can be broken into the little lonely oxygens. We have those hydrocarbons, so other fuel sources. So all of these things can all interact as primary pollutants up here, and then we get some of your secondaries down here. You can get some of the acids, like HNO3. We can get those PANs I just told you guys about. We can get the VOCs, and we can get ozones that can form. And again, this shows us that eventually we're going to form the smog once we get to the secondary stage. Okay, and this is kind of cool because it kind of shows you a timeline of what elements or what molecules might be present during a day in sort of a timeline. So it shows you in the morning, once stuff kind of gets going, you might be releasing some of these primary pollutants like the NOs, the nitric oxides. These can then form nitrogen dioxides once the sun starts to kind of shine and break those apart. And then, once we have even more primary pollutants reacting to form secondary stuff and we really get the sunlight working, and you have lots of exhaust from lots of automobiles out on the road, you'll eventually form that ozone. And so by this time we're really smoggy with the NO2 and the ozone. Okay, and again, this is showing us the timeline throughout the day. Okay, one more time. So your primary pollutants, you can have NO2s and NOs, and some of those hydrocarbons from your auto emissions. You have, and these should be arrows. We have UV radiation that is helping to break up waters, oxygens, and react on these as well. And then here's some of the products you get at the end as your secondary pollutants. We can get nitric acid, ozone, photochemical smog. They could also have the PANs in here. They could also have VOCs. Okay, so those are all different reactions you'd see. Okay, a different type of smog is called industrial smog. And down here at the bottom, I kind of show you the difference here. I said the industrial smog is kind of your old school dirty smog. Photochemical smog is kind of your modern smog with all the traffic and the nitrogen-based stuff. Your industrial smog is like your sulfur-based stuff. So, yeah, think of industrial smog as like the dark, sooty, coal-based, sulfury smog. The photochemical smog, oops, so that's supposed to be an S for sulfur. The photochemical smog is more of that nitrogen-based stuff, okay, that we just talked about. So here it shows industrial smog consists of sulfur dioxide, suspended droplets of sulfuric acid, and just other suspended particles. When burned, carbon in coal and oil is converted into CO2 and CO. You end up with suspended particulate matter like soot from the coal. You end up with sulfur dioxide from burning the coal, which can turn into sulfur trioxide, and then again that can turn into the H2SO4, which would give you sulfuric acid as well. Very importantly, it says this is rarely a problem in today's developed countries because we're not really using coal, because we know coal is kind of old school, coal is dirty, it's outdated, it gives off all that soot. It's bad. If you want to see what a coal-based atmosphere looks like, look at China, look at Beijing. We will look at that. It's very smoggy, very dirty. So it says, but it is a bad problem in countries where large quantities of coal are burned. They don't have very good pollution controls in these developing countries. A good example of that is China. So again, I'll show you pictures and we'll watch the video of that. Okay, and we're almost done. Factors influencing the formation of photochemical smog and industrial smog. You can have local effects like the local climate and pollution, population density, the amount of industry. Sorry, I lost my place here. The fuel, the types of fuels used in the industry and in the city. So again, do they use cleaner burning fuel? Do they use coal-based stuff? And then transportation. Do they have a lot of public transportation? Is it mostly people riding around in their private cars by themselves? Then some topographical issues as well. What are the hills and the mountains like? And so we're going to look at something that's called a inversion here in a second. And so that's where the topography and the hills and the mountains and the airflow of the city really become a big issue as well. Let's see. Okay, moving on. All right, so this inversion I was just talking about, we call it a temperature or a thermal inversion. And so what can happen here is we see these a lot of times in kind of like a valley city type situation. It says here, a layer of dense cool air trapped under a layer of dense warm air, and it says this happens often in winter when the surface air is cool. It's going to prevent upward flowing air currents from developing, and that's going to actually create a lid on top of the cool air. So let me actually show you a picture of this and we'll come back and talk about that. Alright, so this shows how a conversion would form. It says, especially in winter, so you have a low sun, that's going to be less heat actually getting to Earth. So down here at ground level, it's a little bit cooler, where normally down here at ground level it would be very warm. So you've got warm air up here at the top. You've got cool air down next to Earth. Normally we know as air warms, it's going to rise. But since we've got this kind of lid, this little top of warm air and cool air down there, that's why it's called an inversion, because you've got a warm lid, cool down here. Normally it's warm and the warm air rises, but we're not seeing that here. Okay, so warm air lid is going to trap any sort of pollution from fires and cars down in the city. And then here it shows that having mountains being in a valley, and especially trapped in between mountains, can really amplify this problem. So we've had situations occur where you've actually had cities and people trapped in this little valley in between these mountains with this warm air lid, and they're just basically breathing in their own pollution for days or even weeks, and people can die. Oops, so I'm going to go back to this one. It says prolonged inversions can cause air pollution in the trapped layer to build up to harmful levels. So again, it can cause illnesses, it can cause death. LA is the big one in our country. LA is the air pollution capital of the U.S. They have ideal conditions for this smog to build up, and they get a lot of those inversions just because of the topography where they're located. This is supposed to be an animation that doesn't work anymore on this program, so I'll just show you this picture. Okay, so again, this is another picture showing you what's happening. You get your warmer pocket of air above the cooler air down here. We're in a valley situated in between the mountains, and we're a highly industrialized city giving off lots of pollution. So again, if this happened, if the warm air trapped the cool air down here, this city would be kind of trapped in its own air pollution. Okay, only a couple more slides. We have urban heat islands. This is a phenomenon that happens in big cities. Okay, so it says cities can create these little microclimates. So if you've ever been to a city in the summer, you're like, man, it's hot here. It feels way hotter than it does, out in the suburbs, just, 40, 50 miles away from here. You might be right. You might actually be experiencing this urban heat island sensation. So there's a couple of different reasons why it might be hotter in a city than it is in a vegetated area nearby. One of the reasons would be because of a lack of cooling green vegetation. Okay, so you're going to have less vegetation. You're going to have more black tops. You're going to have more asphalt in the city. Also, you have more impermeable surfaces. Impermeable surfaces means that the water is not going to be able to permeate that surface. Okay, so like soil is very porous and permeable. Water can drain into it. With all these black tops and asphalt, the water runs off. So you have less cooling water around. You have less green vegetation to absorb heat. You have more black tops and surfaces that would actually absorb the heat and create a higher temperature there. And then also you're going to have more dust and particulates and air pollutants, and those actually hold on to heat better in the atmosphere. So yeah, cities do have their own little microclimate. We call it urban heat islands. They get hotter. Okay, and the last slide here is noise pollution. Noise pollution is a type of pollution. It just says it's any unwanted or undesirable human-created sound. Some examples of this would be traffic, loud music, airport traffic. This can reduce human quality of life and also animal quality of life. It can influence animal behavior, such as their migration routes, courtship behaviors, their circadian rhythms, like your biorhythms when you wake and when you sleep, those sorts of things. And this is a perfect area for an example of that. We have a lot of those distractions in this area. My neighborhood's located right off of 28, and we're going to be getting a sound wall soon. And of course, a lot of other neighborhoods up and down the Linton Hall corridor have sound walls as well because of all the traffic noise. I actually now I have to sleep with earplugs because I hear the trucks hitting their brakes on 28 all the time. I hear helicopters in the air, airplanes since we live so close to several airports, and just the general traffic noise of 28. So we can definitely relate to that in this area. And that's going to conclude the notes for outdoor air pollution. Again, the second part on indoor air pollution will be your next set of notes. All right, thanks, and we'll see you tomorrow.